All right, so today we're going to talk about normal distributions. So what we're going to do is we're going to look at the normal curve. And so what a normal curve is it breaks this up into items, your mean, and then standard deviation. If you remember back, standard deviation is a number that represents how close your data is together. So in a normal curve, we have here, and it just means that it's symmetric on both sides of the mean. We have 50% of the data below the mean, 50% above it. And so the mean would be our 50th percentile. So if we go one standard deviation above or one standard deviation below, that's going to be 34%. So one standard deviation above is 34% of your data. One standard deviation below is 34%. So if I have an average and I go one standard deviation above or below, I should get 68% of my data. That's what the normal curve is. Two standard deviations, we now increase it to 13.5% on each side. Three standard deviations is 2.35 on each side. Now that leaves 0.15 on the very, very extremes. That's going to be more than three standard deviations. It's a very, very small percentage. So if we look at this in percentile, what's going to happen is we're going to look at how much is it above, how much percentage is it above all of them. So if we're at the mean, we're at the 50th percentile because 50% of your data is below. So if I go one standard deviation above, that's 84th percentile. Okay, so 50 plus 34. If I go two standard deviations, that's 97.5 percentile. Or you are above 97.5% of the population. If you're three standard deviations above, you're at 99.85 percentile. Okay, so it's just these fringe markers. And we're going to kind of give some examples about that. We're going to talk about height, and we're going to kind of look at some examples using the normal curve. So our first example gives us a graph. And we want to know what percentage of people are between 90 to 120. And so what we're going to do is we're looking at 90 to 120. So we're going to look at the percentages on the side. So we're going to take each of these boxes and we're going to add them up. So my first box is here 90 to 100, and it's at about 25%. So this is about 25%. The middle box here, 100 to 110, is about 40%. And then 110 to 120 is 25%. And so we're going to add those together. 25 plus 40 plus 25 gives me a grand total of 90%. So 90% of our data is going to fall between 90 and 120. Okay, so you're just looking at your graph here, and you're going to try and get those percentages. Now, our next example is actually going to be sketching a normal curve. So the first thing we do is we're going to put in our mean. So our mean is our top point, so that's 10. Okay, so and our normal curve is always going to follow this pattern here. So we really are looking at putting in our standard deviations, our first and our second standard deviations. So we're going to draw in our normal curve here. Okay. We're going to put in one standard deviation above, one standard deviation below. So now we're going to look at those numbers. Well, my standard deviation is 2.5. So what's going to happen here is I'm going to add 2.5 to 10. So this gives me 12.5. So this is plus 1 standard deviation, okay? Or minus 2.5, 7.5, minus 1 standard deviation, okay? And so now we're going to go two standard deviations. So this is plus 2 standard deviations, and I'm going to add 2.5 to 12.5 again, and this is going to give me 15. I'm going to subtract off, so minus 2 standard deviations, and this is going to give me 5. Now my third plus 3 standard deviations. I'm going to add 2.5 to that again, 17.5. subtract off 2.5, so this is minus 3 standard deviations. And there's my normal curve drawn up there. Okay, so remember, you're gonna take your mean, that's your middle, your high point on your graph, and you're gonna add and subtract your standard deviation. So the next one is, our last example is kind of analyzing behavior. And so it says the heights of adult American males are approximately normally distributed with a mean of 69.5 and a standard deviation of 2.5. Okay, what percentage of adult American males are between 67 and 64 and a half? Okay, so we're really looking at, so we're going 67 to 74.5. This should be 74.5 here. And so we're really looking at adding these pieces together. So from 67 to 69.5, that's 34, plus 69.5 to 72, 34, plus 72 to 74.5 is 13.5. And so I'm going to add these all together, and I'm going to get 81.5%. So 81.5% of the male population is going to be between 67 inches and 74.25 inches. Okay. What percentage of people would you expect to be above 6 feet? So if my next question is above, so greater than 72 inches, I'm going to look here. So I want all this piece down here. And if we go back to our little piece on the end, this part down here is 0.15%. So we're going to add up all of this, or this is 0.15% here, or we're going to add up all those pieces there. Okay, so I end up with 13.5 plus 2.35 plus 0.15. Right. So that gives me what, 16? 16%. Okay, so 16% are going to be above that. So if I wanted to know out of 2,000 people, how many are going to be above that, I would go 2,000 times 0.16, and I'd be able to find out how many people I would expect out of 2,000 to be above 6 feet. And that's 320. So out of 2,000 people, we would expect 320 of them to be taller than 72 inches. So that's the normal distribution and the normal curve.